Hi, I'm back. Oh, it feels good to be back. Okay, anyways, so we were doing unit tangent vector. Just as a quick reminders, my unit tangent vector is my r prime divided by magnitude of r prime. Basically, it's my velocity divided by the magnitude of my velocity. I'm going to verify that formula if you go back. There it is. Yay. I often use the r's because it tells me how many derivatives I need. And right here we need one derivative, and then we need its magnitude, and we're done. Just in case, I thought we had done this, but we're just going to like quick review back on it. I need to find my r prime. So r prime, what would that be looking right here? Cool. Is there a little bit more? Oh, negative. You said negative. Perfect. Perfect. And then root 2. And then the magnitude of r prime is basically all these different guys, but I'm going to square them. Yeah, I'm pretty sure we had done this. This is a perfect opportunity to review. So the magnitude's always the weirdest one because we got to do a little bit of math. Notice that we have sine and cosine are both squared, and that right there creates a circle, or they cancel, make a 1, whatever you want to call it. Basically, all of this turns into a 4. And then over here, the square root and square cancel to make a 2. Wait, is it 16? Because the square root of 16 is... You got me, bro. You got me. It's 16. Thank you. Improved vision today. Okay, square root 18. Is that what we had last time? Oh, we didn't do it at all. I feel like we did it. Okay. Oh, I didn't do it. Oh, okay. Anyways, yeah, this turns into 16. Just as a quick reminder how that works. Let's say that I square it. So I got 4 times 4 is 16 sine squared. And then I got a 16 cosine squared. And then t. I just made it look junky. Start over. And then plus 2, of course. So here I'm gonna factor out the 16 sine squared plus cosine squared, which is just a 1. And that's how I got my 18. So, cool. Okay, just as a quick reminder. Trig stuff, right? So I'm going to take all this and divide it by square root 18. And so they have it 3 individual boxes, which sometimes gets annoying with this. So I'm just going to remind you, this is sometimes annoying. I'm going to take my my values and divide it by the square root 18. I'm going to take my values and divide it by the square root 18. And then I'm going to take my values divided by the square root of 18. Everything's divided by square root 18. I'm going to go to the answers real quick and flash them. So you can see that it's all like, what, that doesn't look the same. Well, yeah, because 18 is 9 times 2, and then that would be a 3 on the outside. And then the 2 comes up and leaves a 2, and they cancel. So you got square root 3 and like a 2 in there. Yeah, see? Something like that. Or the other way. Square root 2 and a 3 in there. Blah, blah, blah. It's close enough. Cool? Okay, awesome. Now that y'all have definitely done quizzes and stuff at this point, it's been pretty okay with these square roots and the bottoms and stuff like that. Simplify is not too bad. Okay, good. I mean, that was a promise that they gave us, so and I'm happy to hear that. No problems? Sure. Well, sure, yeah, definitely. Okay, so length of a curve. I don't even know what the formula is. Actually, I do. I'm just kind of joking around. I think it was supposed to be the integral. Yeah, x prime squared, y prime squared, z prime squared, dt. We're going t. And let me just verify that. Let's go up. So, yep, x prime, y prime, z prime squared, square rooted, and then a to b. Okay, cool. Yeah, so that's the same formula. Well, we have all these, don't we? Isn't this my R prime stuff, basically? It's coming from R prime. Um, so here we go, I guess. This guy. So I got a negative 4 sine squared t squared. Is this looking familiar? um, and then I've got a 4 cosine square. Nope, no. Did you see it? Did you see it? Did you see it? I put 2 squares. Ah, did it again. Stop that, Chad. Squared there. And then we got the square root of 2 all squared dt. Wow, does that look familiar to you? What is this right here? Yeah, it's the magnitude. It's the magnitude of r prime. That's the actual formula. It's kind of nice. And we actually have the magnitude. If you remember, we like simplified it down to just a square root 18. So I'm saying it's the integral of square root 18 dt. And if I take the integral of that guy, what do I get? Perfect, perfect. I love it when these things are so easy. Of course, they have to tell me where, and they say 0 to pi, so 0 to pi. Plug them both in. The 0 is going to cancel. Put a pi on the outside, and there you go. So that's my answer for that. Pi square root 18. So that was pretty good. I like that. Cool. I want to talk about notation and stuff, but I mean, are y'all okay with like this here, the formula, the math? Good. The what? The easy ones. Yes. 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 Oh, if you have a T left on in the inside, it can get way bad. If you have multiple T's, like in particular, what if you had like a T squared plus T and then dt? Like I'm sure we can maybe figure that out, but it's not easy. It would be, yeah, exactly. It's not something I could just go bloop and get it. It's ugh. So we got to watch out for that kind of stuff. So notation stuff. Notice I can put the pi in the front so that I know that it's not underneath the square root, right? That's one thing. Or if I have the pi in the back, I've got to stop the square root and say, hey, we're done here. 18, boom, and then a pi. And it's just something to notate as we go forward, because we're going to have a lot of symbology. Okay. Do it again. Literally a copy paste. So let's do some R prime action. Actually, you know what? Do y'all want to do this one? You do? You do it. I'll wait for a few minutes. Patiently. This is fun. I love watching y'all work. You pay me so I can watch you work. Yeah. Yeah, exactly. Yeah. Yeah. It's kind of funny how that works. Yeah. Is it getting difficult? I feel like I got to do something too. Y'all don't watch. Y'all just keep doing your thing. Oh, tricky, tricky. Don't y'all watch. Go back to your own work. Gosh, stealing credit and stuff. That's funny. Yeah, just verifying. I like it. Yeah. You know, it is interesting you mentioned the master thing. I don't want to call myself that. Someone else has called me that. Like the university. They gave me a thing. It's called a master's degree. Anyways, so technically, I suppose. But way back in the day, like medieval times, how folks would learn would be, of course, student apprentice, but it was master apprentice, right? And you would, I guess, go see the master and watch what he does, and then you go and replicate essentially. And then you go do you do. It was a lot like we do that for, like, say, blacksmith. You work underneath a blacksmith so you can see how he does the horseshoes and stuff, and then you go and do it. But the same with academics is that I would be working on something, and you're like, oh, okay, and then you go and do something similar on your own. I don't know. That's just old school stuff. Did y'all get what I got, by the way? Okay, whew. Yeah, now's the crazy time. And it actually is not too bad because the integral from 0 to 9 of that square root. Go ahead. So I'm trying to remember this stuff. This is a U substitution thing. Do you want me to, like... Yes? Should I actually do that? Do you want me to do U sub? That's what you're doing? I'll do U sub. Eventually, as we keep going in this class, you'll kind of just hand wave it, and you just know that it'll be fine. So in particular, like, I could just show you the answer, something like that, because you just know what the answer is going to be. You don't have to do all the steps. I wouldn't recommend that, of course, but it is okay later. So yeah, there's my answer basically. Which we'll figure that out here in a second. But let's do the U sub. So, because it's good practice. It's very good to practice this stuff. So U is going to be the inside, and then du is dt, right? Because 16 goes away. We don't need that. And the t turns into a dt. This one is particularly easy. Normally, I go one step further. If you've ever watched any of my videos, I go one step further normally. But because these are literally the same thing, there's nothing else to do. So I go square root of u du, which we know is 3/2 over the 3/2 plus c. But then I plug it back in. From 0 to 9. Actually, the 0 is going to yield a number. Ooh, bad Chad. I was just about to forget the 0 part. Give me a second here. We're going to figure that out here in a second. So I need to plug in the 9. Are y'all okay with this, by the way? The U sub, we're good? Yeah? Okay. I know it's been a long while, at least for me. Like, like literally a long time. Is that 25? Right? That's 25, isn't it? Yeah, so that makes it nice. And then I got a plain old 16. So then how it works is I'm going to do the square root first, because that's the harder one. So if you square root the 25, 5. And so then what you have is 5 cubed. Square root would be a 4, and then you cube it. See how I'm like partitioning in pieces? Yeah, trying to do it all at once is nuts. So, yeah. And I don't want it to get too big because then I don't know the square root of them anymore, you know? But I could do square roots of tiny numbers. 5 cubed is 125. And then that's thank you. Okay, hold up, I got this, okay? The answer is 61. Yay! I don't know. He nodded his head. Did you get 61? Yay! And then with the 2/3 and all that business. Yeah. Like I didn't finish. Oh no. 122 over 3. I'm no. There's probably not a 3 in there, is there? Because 61 that's like prime, isn't it? I think so. At least it's relatively prime to 3. Okay, let's check it out. Let's flash the answers. Yay! We did it. Okay, cool. That was great. So, zooming out. Are y'all okay with this? Yeah? Yes? Okay. Yeah. A little bit of practice on the U sub. That's cool. But kind of like I was saying earlier, you don't have to do it if it's something you already know. Ugh, get tethered there. If it's something you just know, you can just go bloop, 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 and you're done, right? But that's up to you. It's very good to practice and do the long way most of the time. Good? I'm hoping you also notice that I'm really loose with my integral notation. I just kind of throw some stuff up here, like there's a bar, but there's nothing next to it, you know? Other professors might be picky, but we know what's going on. We just don't want to have to. I will not write 0, 9 there, but I could write x equals 0, x equals 9. I mean, that's fine. Or no, what was an x? It was t, wasn't it? But the idea is that I don't want to confuse myself and like, oh, I forgot this or oh that. Just I don't know. Whatever works for you. Yeah, I don't want to do that. Yes. Yeah. Exactly. Like I haven't done USub in like a year or so, let's say. I haven't done that in like 5 years, maybe. And it was only because I had to. All right. So this is a little different. Find the point on the curve at the distance this. What? Along the curve from this point in the direction. Okay, whoa. I have to read this slowly, okay? Find the point on this curve at a distance this much units along the curve from this point. So this is kind of like the start point. And we're going this far. Going this far. I think so. If, as long as t equals 0 here. That's kind of the prereq. And let's verify. If I plug in 0, would I get 050? Which is good. If we didn't, I'd have to back up or subtract or something like that. But because it's 0, everything's happy. I like that. So we're gonna say yay to this. We like that. And so then this is basically my end. So from 0 to this, easy enough. Find the point on the curve at a distance this far units along the curve in the direction of an increasing arc length. Okay. Oh, this is not t equals. This is a distance. It's not t equals. The point that they're wanting to make is I don't know what that t would be. This is L, that arc length stuff. Okay. Yeah, that's what they're trying to say. Find t and then plug it in over here. I think that's what's going on. So yeah, let's draw a picture. So I got this cool curve going on, and over here is t equals 0. And then I have to travel a distance, which I'm going to do like right here, of 52 pi distance. Okay. At the end of that is t equals something I don't know. But that's that point that I also want. If I take that, if I find t, I can like plug it in and get an answer, right? So in a way here, I'm solving for t, given that my length is this much. I think that's the goal. Is that okay with y'all? Good analysis. So L, which is my 52 pi, is equal to the integral from 0 to something, right? I don't know. Magnitude of r prime dt. So obviously we need to find some stuff. Here we go. R prime, help me out. Oh, cosine, you're right, positive. You're right. 5 cosine t, got it. Perfect. I love it. And then my magnitude is the square root of the squares. I almost don't want to write this out because you already know how to simplify some of this. Like all that right there is 25, and that's 144. That's nice. 13? Perfect. So, thank you, MyMathLab. This one's an easy one. From 0 to something of just 13 dt. And what's the integral of 13? 13t. From 0 to box. I'm using box because, I mean, it could be anything. You can use x or whatever you want, but you can't use t because you already have a t, right? So if you want to do like t naught or something, that's fine. That would be more appropriate. X is fine. But ultimately, it seems like when I plug it in, I'm going to get, let's call it x. I think x is going to be an easy term. So I'll use x. So x, and then 13 times 0 is just 13x. And 13x is equal to 52 pi. So I want to solve for x. What would I get? What would I do? Perfect. Is that an easy number right there? Really? That's nice. Now, this is a time value. I don't want to say like t because we were using t as a variable there, but it's a time value, okay? There it is. Plug it back in. So r of x, and again, that's r, not r prime, would be 5 sine of 4 pi, 5 cosine of 4 pi, and then negative 12 times 4 pi. I ran out of room. Hate that. Start over. I don't particularly like using the x. It kind of feels gross at this point. But it'll get the job done. I think what would be worse is just box. So I'd rather take x than box. Why did I put an x in there? Gosh, I'm thinking x and it's actually a pi and then it erases. Oh, Chad. Can't you just get it right one time? Just one time, Chad. Come on. What is sine at 4 pi? And cosine at 4 pi? Yeah, the 5, yeah. And then this dude is... Ooh, I like it. And there we go. There's my final answer. There's my point. I mean, you could do vector or point either way. Let me flash the answer. Yep, perfect. So what's interesting about this problem is the picture. I'm sure we talked a little bit about pictures last time, but what we have here is a circle, and then because it's negative, it's going down over time linearly. And so if you're doing three-dimensional coordinates, it started right here, and it's supposed to just make a circle, but it's going down, so it's actually doing right? Well, our point ended up being, there was the first, there's the second, there's the, oh no, that was 2 pi, this is 4 pi, right? 4 pi into it, this is 0, this is 4 pi. Look, it's literally on top of one another. That's why we have the 0, 5, 0, 5. Where was my initial point? 0, 5, there we go. So we started at 0, now I just went down a lot. I don't know. Whoa, cool, Chad. Whatever. Just we got the answer. It's good enough, Chad. I know. So exciting. Cool. Any questions? Okay. Awesome. Okay. This is just arc length, and I think it's a very easy one. So y'all do that one. It's kind of similar to what we just did, but I think it's easy. It's almost too easy. Why did I put that in there? Oh, yeah. I was giving Crucilian good. My math lab's been working pretty well for us. Having when problems come up. But I warned her also that this is the easier half of Cal 3. We haven't really got to something too difficult yet. Soon enough. And it's not triple integrals either. That's the easy stuff there. It's the chapter 16 Stokes theorem, and Green's theorem isn't too bad. Divergence theorem's easy. But Stokes, I always have a Stoke when I see Stokes. It's a half joke. You're already done. It's that easy. Yeah, because we just did it. We just did this one, right? I know. I'm just seeing if I can get this. I'll explain it here in a second. Yeah, this is literally a copy paste to what we just did, right? So, okay. Are y'all okay? Let me real quick recap. So, R prime, are we okay with sine cosine? It's easy stuff. Again, magnitude of R prime, notice that again, I'm going to use a different color. Notice that again, we have this circle action, which just turns into the 25, right? So I can like skip that step, and square root of 7 turns into 7. Cool. Integral of whatever without a t, you just add a t in there. Plug in your numbers. 0 cancels. We get it? Of course. You couldn't just leave it 32, okay? Yeah, well, they can. Good? Okay. Cool. The T out. Oh! Whoa. Ooh, you were going down a bad road. Yeah. Which means trig sub and stuff, right? So you had like a t squared plus stuff, and you. Good. Turn around, don't drown. That's, yeah.
The water is getting really close to inside the car. Let's keep going. No. Okay. That's a fun one. Okay, let's see what else we got. So arc length parameter of a curve. This okay. I mean, why are they using a tau? So that's this symbol, which is a tau. Why are they doing that? I don't know. Find the length of this. Okay. So the arc length is pretty easy. The length of the indicated portion. What? Arc length parameter. Oh, I got it. Okay. What are they asking for? Well, we're going to do here in a second. But they're trying to say that this is a formula versus a number. Okay? Like after we plug it in. So they want the formula without plugging it in. Okay? At least I think so. We're gonna verify here. Okay? So R prime. Ooh, this one's more scary. I love it. Notice that we have product rule, right? So we got F and G. And y'all remember product rule, right? F prime G plus FG prime, or whatever version you use. It's been a while. So then I'm going to say the derivative of the first one, and I'm going to use the 2t together because it's easy, just kind of put it in there. For me, at least, y'all can do whatever, but I put it with one of the groups. So F gets that guy. So the derivative of 2e to the t is 2e to the t. But then times the cosine of t, because that hasn't changed, plus. Then I leave the 2e to the t the same. It's like that's a derivative, that's not a derivative. But then derivative of cosine makes a... Yeah, negative sign, exactly. I'm going to go down with this, because otherwise I'd run out of room. Same with this. I'm going to group the 2 with the e thing. So the derivative of e to the t is e to the t. No changes there. And then leave it alone, and then take the derivative of sine goes to cosine, yeah, regular old cosine. And then this guy here, I think it's just the same. Cool. Okay. So yeah, let me redo this. So this was f prime g plus f g prime. That's the formula I was using. Awesome. Well, we need to find the magnitude of all this stuff, which is now going to be very interesting, right? I'm going to start over here because I need a little bit of room for this. Whenever you saw it, you just jumped into it, bro. You were like, Chad, I'm ignoring you. Boom, boom, boom. Did you finish?
I don't know what the first person's asking. I think I got the link.
Okay. Yeah, we're gonna figure. Yeah, I don't know what the first one is. Yeah.
I'm wondering if once you start to see complex K's, or at least all
Right. Well, they're all the K's are always similar to the magnitudes. Hey, thank you. So yeah, they're really similar to the magnitudes. They share the same magnitudes, which is nice. Yes, but later you're right, not as so nice. Okay, so let's do this thing. I'm gonna start putting this stuff in. I'm gonna factor out a 2e to the t and leave whenever I put a parentheses, I think it's a c. A cosine minus sine. And then I'm gonna and then all this is squared. And then factor out the 2e to the t again. This time I have a sine plus a cosine. I hate putting little t's on them sines and cosines. And then I just have this 2e to the t, and that whole thing is squared. Okay, so this one looks a lot wild. Okay, so the square is going to apply to all this stuff. And you know what's interesting? They all have a square of 2e to the t, right? So if I just look at this guy, it's kind of applying to all of them. Square, so I get a 4, and then when I square, I get perfect. And so what I have now in the front of every single one is this guy, which we'll pull him out here in a minute. Now for the craziness. So I need to FOIL this guy out. And so if you look at it, we're going to get a cosine squared minus 2 cosine times sine, and then plus sine squared. I always get a plus at the end because 2 negatives will make a positive. So that was just, I don't want to do that. Hold on. There, get rid of that parentheses because we got others to do. And then this guy, similarly, sine squared, 2 cosine sine, and then cosine squared. Whew. So just that, I don't want to have too many colors going on, but this group went here, here, and here. This group went here, here, and there. Okay. Ah! You got me, bro! You got me! Thank you! I would be missing a +1 at the end. I would say, oh, this is an easy problem, right? No problem. No, +1 blows the whole thing out. Thank you for that. It's because I had factored and I forgot. You're right. Okay. Ooh, yeah, so that one goes to a 1. I have to mess up at least once. But notice that when I FOILed these things out, something's going to be nice and happy for us. What happens? Yeah, we have a lot of canceling stuff, right? And then these guys combine. You're not my partner. These combine. Those combine. Hi again. And so then, actually, hold on. Go ahead. This guy and this guy? Oh, yeah, we will make a 1. Yes. Yeah. I just have to, mush them together first. Yeah, let's do that. I like that. 2t. So then I've got 2 cosine squares, and I got 2 sine squares, and then plus the 1, of course. And you're right. These guys are going to make a 1, but not a 1 now. It's going to make a 2. Very good, because there's a 2 right there. Perfect. So then we got a 2 plus 1. Now, that's going to be a 3. We all know that. That's fine. But don't make it into a 12. We're not... Go away. Okay, there we go. Don't make it into a 12 because these can come outside of the square root. And let me do that slowly so that we're all on the same page. There we go. Square root of 4 is a 2, and the square root of this guy ends up being plain old regular e to the t. So this, I found, was my magnitude of r prime. We're not even at the arc length part yet. So this is a pretty big problem. That's good, though. That's good. We need some of these. Any questions at this point? No? Okay. So now we need to integrate. We got room. Plenty of room. Look. So much room because it's the end. So, yay. So my S is my arc length. The L that they were saying earlier is integral, And again, I don't want to put terms in there right now, but I do want to put this guy in. 2e to the t square root of 3 dt. And so when I integrate, what do I get out of this thing? I think mine, except for the 1, it's the same. I think. The reason why the 2 and the 2 go the same, and the square root of 3 is square root of 3, but integral of e to the t is e to the t, right? Cool. Plus c, technically. Plus c, technically. Very good, very good. Let me find out though. I want to pause right quick because this is that moment. Is that what they're wanting me to say is S? Is that their answer? Do I have to do something else? I don't know yet. See, they got stuff here, and it's. I'm thinking so. So notice that because the minus sign, what I'm thinking is that they actually applied a definite number of some kind. And so this is my thoughts. I know this is going to be kind of weird. Let's get rid of the C. Yeah, they're finding C essentially. But I want to do it proper. Let's say that they're going from 0 to something else. Okay. And the something else, and this is where I don't like having to do this. This is, if you go back up to the top, this is why they use tau. Because it's like a T, but it's not a T. And that way they can get away with it. Remember last time I had used X? Because I wanted like some letter. No, it was this one. I had to use some letter. They're using tau. But either way, let's just say that this is like a T kind of thing. And I'm gonna pop that in and pop this in, okay? So I got 2e tau, or T, or just let's call it T. Let's just not be dumb. Let's just call it a T, okay? It's fine. Square root of 3, and then minus 2e to the 0 square root of 3. Oh, there's that 1. Because this guy turns into a 1. You're right. You were working ahead, and I was behind. There we go. And there it is. Pop-up. We got what they got. For part A. So, no, it's fun. It's fun. For part B, what t value are we plugging in? Did they say? Yeah. It's weird. And notice that they're going this way to 0. Like, shouldn't it be like reversed? So I'm already really not liking what they're doing, but oh well. Yeah, let's say that t is equal to negative ln of 4, and I plug that in. You know what? You mind? You don't mind? Sure, Chad. Can I do that? It's way easier, isn't it? Negative ln 4. Ew. Man, I haven't done logs in a long time. Actually, I do it every time in algebra. So let's go back through logs a little bit. Notice that we have a power that's a negative. So what's going on with the whole thing? What? Yeah, divide. Exactly. You got it. It's a fraction. Very good. And then e and ln, they cancel out. Very good. So then I basically just get a 4 right there. And 1 minus a 4th, I'll take it. I think I can cancel my 2's a little bit. Negative? Ew. Do you see how they got a positive? So, did they just say absolute value of that? Probably. That's what I would say that, yes. Yes. Yep. They flipped these around. So they gave us a formula and they said, no, wait, don't use that formula. Go and do it again. Right? I mean, it's so stupid. So yeah, they flipped these because they put 0 here and then a number right there, which I don't know why they would do that to us. So yes. Okay, cool. So in the end, like recap, what do we do? Well, we took our product rule stuff, which is fun, and we expanded and canceled, and cancel, got to something really nice. Arc length is the integral, which is super easy, and that's what they wanted. And then after that, we plug in the number they give us, basically. We still got 13 minutes. Chad, it's now 12. Oh, go ahead. I'm sorry. I can wait. I can chill out. In fact, I got a text message, just so you know. No cellular devices in class, guys, okay? Oh, sure. Um, yeah, there's that. I don't know. Did I do that policy thing with y'all? Oh, I did? Okay. I have to do it with all the classes. No cellular devices in class, and no food or drinks except for coffee and all that. It's just, I know, right? Bro, it doesn't matter. It doesn't matter. Anyways, it's just funny. Are you good now? Sure, no problem. I'm fine with however long. All good. Cool. Let's see what's ahead. Oh, great. So, I have to say, what we've been doing so far has been actually not too bad. This is much worse, and it's only when it's worse whenever there's something crazy here. Because basically, to get the unit normal vector, you have to take this and like go back into it. You can see that's my t prime. So yeah, and then these are not fun either. What I did is I stole these from the other book because the other book has better formulas. The formulas I like to use for this are right here and right here. Sometimes, occasionally, this one's better, but I don't know. I like those two. Those are really good. The curvature formulas are really nice. This one in particular is super awesome. I love this one. I would say definitely we need that for our notes. And then you could use, I've used this once in a while, not often. So what is all this stuff going on? So whenever we have a curve, we have a tangent vector coming from it, right? That's easy enough. But there's also a perpendicular and orthogonal normal vector, right? So this is always 90 degrees, and that's how they're going from here to here, essentially, okay? Blah, 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 blah. Well, with every one of these circles, we also have, I said circles, I just gave it away. There's like a circle that kind of emulates what's going on at the moment. Is it normal this, or is it that way? I think the normal is the other way. Do y'all know? This is physics, centripetal force. Does it go inward or outward? Inward? It goes in, not out? Okay, it goes in. Well, okay, either way. I can't remember. It's one of those, but like if it wasn't this, you just do make it negative, okay? No, it's either way. They're orthogonal. I can at least say that much. But every one of these is emulating a circle of a kind, and this circle is defined by this curvature. Now, the formula for curvature is very simple. The curvature is 1 over the radius, or radius is 1 over curvature. So if you find your radius of this imaginary circle going on, then you would just say flip it and there's your curvature, okay? The more curvature, the less radius. The more radius, the less curvature. For an example, let's say that I had this as my curve, and I needed to emulate a circle. I needed to emulate a circle for this, right? Do you see what I'm kind of getting at? What's my radius? It's huge. So my curve, right, and so my curve, how much curve do I have for this line? Very little. Right, exactly, very little curve. But if I had something like this, you could see that you can see a circle in there. So I have a very small radius, and therefore a very large curvature. right? So they're inversely proportional. Anyways, it's really cool. Not that you have to have all that, but I think it's neat. Like, but going forward though, these are really important because we can find these A's and V's. That's just R prime, R double prime, right? Those are easy to find. So we like those formulas. This one's super fun if you have only a y equals blah blah blah. It's like two-dimensional. So this is for 2D. Like, this is the formula to use, okay? Because it's just you plug it in and you're good. It's so nice. And then if you have 3 dimensions, then I would go with this guy. Because again, R prime, R double prime, these are things we have. Okay. All right. So let's do some of this stuff, right? Oh, look at that. They got cool pictures. Hey. And so yeah. Oh, the normal is going in. Look at that. It was one or the other. So you can see they made this imaginary circle that kind of replicates. It's replicating this area, approximating it, but obviously it doesn't hold forever because it keeps changing. Oh, there you go. This is rho, which is your radius. I don't know why they had to use rho, but whatever. It's R. It's R. It's fine. And that's definitely not just a K. That's now a kappa. Okay. Goodness me. So rho and kappa. Good. Did they use Greek letters? Okay. Yeah, because we ran out of Latin characters, so we have to start using Greek. Yeah. Okay. So let's start this one out. I don't think we're going to get done, but this is a very classic problem. Find T, find N, find K. Go. And so this one, it doesn't look that bad. It's only two-dimensional. So let's do it. At least let's start it. R prime. What's my derivative here? Yep. And then this. Ooh. What's my derivative of ln a cosine? Mastermind? No. Hold on. Let me try this. So derivative. I'm gonna say derivative ln is 1 over stuff. So then I got 1 over my stuff, and then I have to multiply by the derivative of the inside. Derivative cosine makes a negative sign, right? But now that's on the top, and so then I got a negative sine over cosine. Sine over cosine is a tangent. Did you say that? Oh, okay. Cool. Oh, I see. You were just, yes. I see what you mean. So negative 7 tangent t. And then that's it. We only have 2D here, so at least it's not that bad. Let's go ahead and find R double prime just in case, because we might have to use it. What do we get? Derivative tangent is secant squared. Yep. You got it. Now, I don't know if we're going to use that or not, but we definitely will have it available to us. So now let's go and use, let's find the t. So then I have 7 and negative 7 tangent t all over the square root of 7 squared, 7 squared tangent squared. So I don't really care what the top looks like, but I want to know what the bottom is. Notice that they both have a 7 squared. So I could factor that out, and then I could pull it out. 7 square root of 1 plus tangent squared t. I know I've seen this before. What does that end up being? Straight up, not a negative? Cool. Well, that's a good thing. Things are looking bright. So that is my answer for T. I'm going to flash the answer real quick. What? Is that, are you joking with me, bro? Are we looking at the same problem? Oh, okay. I just zoomed in. Okay. Well, wow. Um. Oh. I have to. Yeah, I have to simplify. Uh, yeah, exactly. So the sevens are all going to cancel. And so I have this. Oh, you know what? Look, it's the square root of secant squared, isn't it? Which makes it just a secant. So sevens cancel. 1 over secant is the cosine. And then tangent over secant. So we got sine over cosine divided by 1 over cosine. Hi. Cosines cancel and we get negative sine. That was a negative. Okay, so now did we get what they got? All right. Simplified, Chad. Is secant. And then I still had to do the square root, so I just totally forgot about that. Okay. So we got at least that far there. That's a good thing. Now, when you have an easy t, your n is easy, which is very good. And so I'm going to do the n right quick with you guys. So n is going to be t prime divided by magnitude of t prime, right? So we need to find t prime. What's my derivative of cosine? And then derivative of negative sine is negative cosine. Yeah, you got it. And then what would be the magnitude of this thing here? Exactly. Wow, that was an easy one. Flash the answer. Negative. Yep. Look how fast that was. Damn. Will not always be this easy. Will not. And it's not because it's 2D, though. That does help. It's that it just turns out nice. Hi. So, and then we don't have enough time for this. I want to do this guy, but what is their answer? Oh, wow. That's not fun. We'll do that next time, okay? I have ideas. There's 2 ways we can go about this. Because it's 2D, I could use that formula, but I have to do it a little differently. Or I could just go back and use R prime, R double prime. Are we cool here? Okay, I'll leave it. I'm going to real quick turn it off, okay? No more recording.